I'm going to use a model to show you the process behind adding two fractions with different denominators. What this model is showing us is 1/2 plus 1/3. So I wrote that down up here so you can see that. And what you can see in this model is that 1/2 is equivalent, the same as 3/6. So 1/2 and 3/6 are the same thing, it's just different size parts. And then similarly, the 1/3 here is similar to 2/6. So 1/3 and 2/6 are equivalent fractions. They're the same value, it's just different size parts. And what this model lets me see is that 1/2 plus 1/3 is the same thing as 3/6 plus 2/6, which is a total of 1, 2, 3, 4, 5, 6. And what you'll notice is when we add fractions like 3/6 plus 2/6, you only add the numerators, the top numbers. You only add those two together and your denominator stays the same. The reason is because you're just determining how many of those 6 you have combined together. So in this case, we have a 6. How many times do we see it? 1, 2, 3, 4, 5, 6 total. So 5, 6 is our answer. So just be careful with the common mistake that 3/6 plus 2/6 is 5/12. That is not correct. You do not add the denominators. You only add the numerators because, again, we're just counting how many 6 we have all together. So it's easy to tell how to add these up if you're given a visual model. But how do I add these two fractions with different denominators if I don't have a picture to look at? So you have to first look at what's going on here. So we know that 1/2 and 3/6 are equivalent, and 1/3 and 2/6 is also equivalent. If you look at the 1/2, that part right there, and you look at the 1/6, you can see that the 1/2, we went from 1 part to 3 parts total. So basically, this tripled in the number of parts total. And you can see here that the 1/2, if I were to triple the value of each of these, that will give me the value 3/6. And then similarly, the 1/3, you can see we have 1 part here, and that was doubled. So if I were to take the value 1/3, if I were to double each of these values, you can see that I'll end up with 2, 6. And then the other thing to pay attention to is that if you were to recall finding the least common denominator of fractions, or the least common multiple of two numbers, that is the connection between what we have here and the number 6. So if you look at the 2 and the 3, the least common multiple of 2 and 3, you can see here is 6. So by using the least common multiple of these bottom two numbers, my denominators, that allows me to figure out these slices in the case when I don't have a picture. In other words, if I'm given two fractions with different denominators, I want to add them without using a model like this. I just look at your denominators and I find their least common multiple, like I did here, and it's 6. And then you're going to come up here and you're going to rewrite each of my denominators into a 6. And then the next question you got to ask yourself is, 2 times what number will give me 6? So I know that 2 times 3 will give me the 6. And whatever I do to the bottom number, I'm going to do the same exact thing to the top. Just like we saw over here, that the 1/2, we have to triple each of these values to get the 3, 6. So by tripling each of these, I get 3/6. And then the same idea applies to the other number. I have a 3 here. I wanted to change it to a 6. So what times 3 will give me 6? I know that's going to be 2. So I'll double this, and I also double the top, the numerator, and I get 2/6. So just like we saw before, the 1/3 became 2, 6. So we have to double each of these values to get our equivalent fraction. So once you find the least common multiple of these two bottom numbers, and then you rewrite it in terms of your equivalent fractions, all you have to do is add your numerators together. So 3 plus 2 gives me 5. And your denominator, we keep the same, because as we saw over here, all you're doing is counting how many of those slices make up the whole amount. So now we're going to look at a couple of examples on how to do this without a picture. So just like I mentioned before, the first thing you're going to do is first find the least common multiple for these two bottom numbers. So when I did the work here on the side, I can see when I count by 3s and I count by 4s, the first number that matches up would be the 12s. So that means that I'm going to rewrite each of these fractions. My new denominator is going to be 12. And then the next part is to say, okay, I want this 3 to become a 12. So what do I have to multiply this number by to make it into a 12? This number has to be multiplied by 4. And what I do to the bottom, I have to do to the top as well. And you can see here that 4 times 2 will give me 8. And 4 times 3 here is 12. So 2/3 is the same as 8/12. Similarly, I want to rewrite this 4 into a 12. So I just ask myself, 4 times what number is 12? In this case, it'll be 3. And I'm going to do the same to the top, the numerator. And I multiply it out. 3 times 3 is 9. And 4 times 3, you can see, is 12. So now that I rewrote my equivalent fractions, I just add my two numerators together, I get 17, and my denominator stays the same. So 2/3 plus 3/4 is the same as 17/12. All right, and here's the last example. First thing you do always is to look at your denominators. So in this case, it's 4 and 16, and you're going to find their least common multiple. And remember that when I find the least common multiple of my denominators, a faster way of saying that is you're finding the least common denominator of these two fractions. And you can see when you write out the multiples here that the first number that matches up is going to be 16. So that's going to be my least common denominator. So that means I'm going to go over here. I'm going to rewrite each of my fractions. My new denominator is going to be 16. And then it goes back to the same process. So you look at your denominators and you say, okay, I want 16 to be equal to 16. Well, this one's easy because I just got to multiply by 1 to both of these. And you'll notice that I didn't really have to do any work because 3 out of 16 is the same thing as 3 out of 16. So that's going to stay the same. So again, if your denominator is going to be the same, you don't have to change your fraction. And then for this number, it's a 4. I want it to be 16. Therefore, what times 4 is 16? 4 times 4 will give me 16, and I'm going to do the same thing to the numerator up top. So 4 times 1 gives me 4, and 4 times 4 is 16, which we already have. Now that our denominators are the same, I can see 3/16 plus 4/16 is equal to 7/16.